Hey guys, I wanted to put together this hypothesis interpretation video for you that really relates more to the ACT than what it does the SAT. So with that in mind, you're going to encounter a hypothesis section on the ACT science test every time you take an exam. And when you do, you must read the entire hypothesis section of the exam. So let's walk through it together so I can show you some ideas on how to get through it. Okay, notice in the upper left-hand corner, we have a graph with a paragraph attached with it. Take note of the italicized words and how they are spread out through that paragraph. Notice paramecia, P. caudatum, and P. aurelia. You see the two italicized words, and then you come through towards the end of the paragraph and you see population density italicized. The way they are distributed through that paragraph suggests that you should read it. Don't try to skip it because it's going to have some valuable information in it. So let's go through this paragraph and let me help you find some information that may be very vague, that you may overlook. Students grew two different species of paramecia, caudatum and aurelia, together for 18 days in a test tube containing growth medium. A constant supply of bacteria was maintained in the growth medium. Figure 1 shows how the population density of each species changed over 18 days. Okay, so we've got an idea of what's going on here. There are two paramecia in a test tube with a growth medium and bacteria. Now let's be a little bit more specific about this. The bacteria is a food source for the paramecium. The growth medium, as you look, it's a constant supply of bacteria was maintained in the growth medium. So that's implying that the growth medium is a food source for the bacteria. Now let's go on a little bit further to the last set of parentheses. It says number of paramecia per milliliter. Milliliter is implying some type of volume, right? Volume of what? Some type of liquid. Well, what type of liquid? They don't tell us. But if you'll think back to your biology courses and think about paramecia, where do you normally find paramecia? Well, you find it in the water. So therefore, the test tube has to have water in it. So now you know the test tube has a solution of two paramecia, a growth medium, a bacteria, and water, so that the paramecia can survive. Now let's look at the first graph. The first graph is showing us the relationship between aurelia and caudatum. Go to the y-axis. What are we measuring? We're measuring the population density. So how many paramecia we have of each species, right? The x-axis tells us that we carry out the experiment over 18 days. But what do the lines tell us? At day 0, all the way to about day 3 or maybe day 4, they both grow in unison with one another. Nothing's happening between the two, but right about day 4, they split. Caudatum increases real fast, and then aurelia continues to multiply. But caudatum around day 7, maybe day 8, if you will, begins to decrease in number. Why? What is going on in the test tube that is making caudatum decrease? Well, this is where we begin to create our own hypothesis. What can aurelia be doing to caudatum to cause caudatum to decrease? Well, aurelia could be producing some byproduct. And when it gets into the solution, it causes caudatum to die off. Okay, aurelia could be ingesting caudatum. Well, maybe Aurelia could also be outcompeting caudatum for the food source, which is the bacteria. Now you have got three ideas or three possible hypotheses that could be going on. The next thing you have to do is you have to ask yourself, well, how can I test this situation with caudatum? What would I want to do with caudatum to prove that, or possibly prove that Aurelia is doing something to caudatum? Well, in the graph below, they illustrate that they pair caudatum up with another paramecium called Brusaria. And both of those grow in harmony. Neither one of them has any negative effect. So that goes back and it tells us about the first graph that, hey, Aurelia in the relationship with caudatum, something is happening that's possibly due to Aurelia. So students 1, 2, and 3 are going to produce their hypothesis based on that relationship. Now, you've got to read this because you have to identify the similarities and differences between student 1, 2, and 3. You've got to identify their hypothesis no matter what. Student 1 says caudatum and Aurelia can grow only near the surface of the growth medium. As the population densities increased, competition for food increased. Eventually, one species outcompeted the other. So he's thinking, or she's thinking, competition. What else is there that student 1 thinks? Unlike caudatum and Aurelia, Brusaria harbor cells of photosynthetic algae called Coriella in their cytoplasm. Coriella produce O2 for Brusaria. This allowed Brusaria to feed on bacteria at the bottom of the growth medium. Because caudatum and Brusaria occupied different regions in the growth medium, there was little competition for food between the two species, and they were able to reach stable population densities. All right, student 1 tells us about the entire relationship. Student 2, what is student 2's hypothesis? Initially, caudatum and Aurelia fed on bacteria, but Aurelia can also feed on other paramecia. You see the difference already between student 1 and 2? Thus, when the population densities increased and the competition for bacteria increased, Aurelia began to feed on caudatum. Then student 2 goes on and says, caudatum and Brusaria were unable to ingest other paramecia. So caudatum and Brusaria were able to reach stable population densities. Student 3, what is their hypothesis? Caudatum and Aurelia were able to find food when their population densities were low. When population densities became too high, Aurelia released a toxin that instantly stopped the cilia on competing paramecia from moving. Because the movement of cilia is necessary to ingest food, the population density of caudatum declined. So student 3 is going with the toxin. Okay, what else do they say? Caudatum and Brusaria were able to reach stable population densities because neither species can produce the toxin. All right, now, we clearly see the three different hypotheses that each of these students have. We've clearly made in the beginning some hypothesis ideas for our own self. Some of our hypothesis matches students 1, 2, and 3. By predicting your hypothesis, it helps you have a task to follow when you read students 1, 2, and 3, and it keeps you engaged instead of getting bored. Finally, you'll be happy to know that the questions that they're going to ask you is completely wrapped around the hypothesis of all 3 of these students and graph interpretation. Now you've studied the graphs properly. Now I've shown you to read them, the students properly. And at this point, you should be able to go on, answer those questions quickly without flipping back and forth very much to grasp information. With that being said, I hope this has helped you. And if I can be of any help to you, please reach out to me. All the best.